Okay, so here we have the problem kind of set up. What I've done is I've broken up the givens, the initial information that we have, into multiple sets of problem types. Specifically, I looked at this and I saw I have a lot to do with force, I have a lot to do here with the kinetic energy, a lot to do here with the kinematics, and a lot to do here with the thermodynamics. And I'm trying to get to this energy that we've put into the car. How much energy do we need to put into the car? And the difficulty here is that we have a lot of givens, actually. And you might think that an abundance of information is a good thing, but it's actually kind of a bad thing in this case. Now, a couple things we can do right off the bat is if we're looking to really just do the type of problem where we can eliminate options based on whether or not we can get some sort of a number right away, the kinematics goes away and the thermo goes away. The reason is, well, first of all, this is essentially our end goal, is to get to be able to do the thermodynamics part. So that's not going to happen until we're over here anyway. The kinematics, you can see we have a lot of information but not quite enough to do anything. So I'm going to ignore that for now. So that leaves me with two other options here. And before I really approach those, one of the things that becomes apparent as you look at this is that one option from the end really is to deal with an equation like efficiency equals work over QH. And here I'm using this sort of set later on. I'm saying, yep, I have some information on this. Obviously it's important because this is what I'm trying to find ultimately. So really what it indicates to me is that if I can find out what the work is, so if I can get work equals QH times the efficiency, if I can figure out what the work is, I should be set. So now what that leads me to try to realize is that the two things that I need here, if I'm looking at kinetic energy, I'm probably going to be looking for, at some point, work equals change in the kinetic energy. And what we'll find out is that this path is actually by far the easiest because we have the change in kinetic energy if we just do a calculation. Up here, it's a little bit more challenging, but I'm probably going to be looking for something along the lines of work equals force times the distance. And this will be the force of friction, really, is what we'll be interested in, because friction is what's moving the car. So if I can deal with this, if I can get something along this lines, it'll give me the work, which will allow me to substitute in here and solve for the QH. Unfortunately, until we get what the work is, we're not going to be able to get there. If you decide to go the force route, which is perfectly viable, it might be useful to set miniature goals, so to speak. There's a lot of steps that we normally put all in one, but you could set a mini goal for yourself somewhere down here of, let's try to get to that force of friction. And so what information do you need in order to get to the force of friction? Another thing that you can get out of this region is acceleration. So how do we get to the acceleration then as well? So you kind of set little miniature goals for yourself, and how the path plays out could be a little bit different, but here we need to find out what the force of gravity is, and then we need to find out what the normal force is, and then from there we can go to a little bit curvy line, we can go to what the force of friction is. So we can set these miniature goals, get the force of gravity, get the normal force, get the force of friction, and then from there we can hop along and get the acceleration. And hopefully that will give us at least enough information to kind of go back down here then to the kinematics and solve for the displacement and ultimately finish this up.